Hello and welcome back to Example 2. In Example 2, we are given that the segment NM is congruent to segment KL and that NK is parallel to ML. That's what this little notation right here means, is parallel to. We need to prove that triangle KLM is congruent to triangle MNK. So the first thing we want to do when we're writing a proof is jot down the givens. With that in mind, we have a set of sides here that are congruent to each other, and these little triangles right here mean that they're parallel. Parallel doesn't mean congruent, and we have no way to prove that these are congruent. So if we could have proved that all three sets of sides were congruent to all three other sets of sides, then we would be able to use SSS. However, we are going to have to confine ourselves to SAS, the only other weapon in our repertoire. So with these parallel lines here, we will be able to show that one of these sets of angles is congruent. So think back to Chapter 3. In Chapter 3, we talked a lot about parallel lines cut by a transversal. So let's say this line represents the line that contains NK, and this line represents the line that contains ML. This line right here represents the line that contains KM. So with those set of lines, the angles that we can show are congruent to each other is this set here of purple alternate interior angles and this set here of red alternate interior angles. And if we put those on our original picture, and anytime you have a picture, I highly suggest that you draw on it. Here we would have the red set of angles, and here we would have the purple ones. Now remember, we're marking these congruent because anytime we have parallel lines, the alternate interior angles are congruent to each other. Now, we know that KM is going to be congruent to itself. That is going to provide our second set of sides. So we need to choose, do we want the purple or the red angles? Well, I love purple, so that's probably the one that I would pick if I didn't know better. However, if we used the purple angles in this proof, we would end up with ASS. ASS is not a valid congruence theorem. If you can't say it at school, you can't use it in math. Side angle side has to have the included angle, the angle that is between these two sides. So no matter how much I love the color purple, we are going to have to go with the red angles. So that's going to be the next line in our proof, is that angle NMK is congruent to angle LKM. And those are alternate interior angles. The next line, we are going to state that KM is congruent to itself. We've already talked about that's using the reflexive property. That's stuff that we've been using for a long time. So we have one set of sides, the included angle, and another set of sides. So we have all the prerequisites to use the side angle sides congruence theorem, or postulate, sorry. So we finish our proof with triangle KLM is congruent to triangle MNK by the SAS congruence postulate.